The release of Blender 3.5 is quickly approaching, and I wanted to share how to use some of the new nodes that are coming. I mentioned all the new nodes in a recent video, but I wanted to show you how to use the nodes related to images and why they're useful. The image texture node has been a thing since version 3.0, but now we have an image node and an image info node to go along with it. The image node allows us to select an image one time and use it in many locations. It's similar to the dry concept in computer programming, which states do not repeat yourself. The image info node allows us to extract information about the image and use it to drive things within our node tree procedurally. Alright, so this is what we're going to be creating, but I'm going to break it down into a bunch of sections. In this first section, we're going to be generating some geometry. Then we'll separate the geometry based on their index and subdivide them. After that, we'll remove some of the geometry based on an image. Next, we'll crop the edges to form a rough rectangle. After that, we'll smoothen up the edges. And finally, we'll use the new image nodes to color it and automate some of our work. If you want the project file, a link to it is in the description. All right, start a new project. As usual, begin by going to the Geometry Node tab and clicking New. For this, we need to generate a grid of equilateral triangles. Start off with a grid. If we rotate the grid by 45 degrees, and then scale it up by the square root of 3. We'll end up with this rhombus shape. If we cut this rhombus in half, we'll have two equilateral triangles, which is exactly what we want. However, we need a series of these so we can subdivide them by different amounts. All right, so to do that, add in a instance on points just after the grid, and then add in a mesh line and put that above the grid. Now connect the mesh to the points. If you hold down Alt while you put it on points, it'll automatically move the mesh grid down to instance. That's a new feature in 3.5. All right, now set the count to 4. Or however many you're planning on doing. And finally, for the size of the grid, change that to square root 2. Quick little side note before we continue. If we bump up the vertices to say 20 and triangulate the geometry and then add in a dual mesh, we'll get this honeycomb pattern. I haven't seen anyone use this method to generate a honeycomb pattern, and it's pretty simple. You don't have to modulate indices or anything crazy like I see a lot of other people do. It just works. You could then use a delete geometry node to trim off the corners and make any shape you desire, which is what we're going to be doing in the next bit, but with triangles. All right, so remove all of this and switch this back to 3. All right, back to the tutorial. The next thing we need to do is separate the instances based on their index. Let's add in a separate geometry and set the domain to instance. Then place an index and a compare. Set the compare node to integer and the operation to equal. And set the B value to 3. Connect index to A and result to selection. Now when the B value is set to a valid instance, that instance will appear. We'll have to realize the instances eventually, and there's no better time to do that than right now. So add in a realize instances just after the separate geometry. We can now subdivide it. So add in a subdivide mesh just after the realize instances and add in a math node just before it. Keep it set to add, then place down a group input, or bring up the side panel with N, and then on the group tab, add a new input, set its type to integer, name it subdivision level, set the min to 0 and the max to 6. I cannot overstate just how important it is to set the max level. Connect the subdivision level to the first input on the math node and set the second value to 3. Then connect the output to the level on the subdivide mesh. Now we need to copy most of this for each iteration, so we're going to select everything accept the index and the group input, and we need to duplicate it 3 times. So I'm just pressing Shift and D to do it like that. Now there might be a more procedural way of doing this step, but since the subdivide mesh doesn't have a field input, I'm not sure how that would work. If you know, please leave me a comment. Connect everything the same way as this first one. So the index is going to go to all these compare nodes. The subdivision level is going to go to the math node. And the geometry is going to go to the separate geometry. Then at the end, we're going to add a join, if I can spell, a join geometry node, and then connect all of them to it like that. Right now we have all 4 of these, but they're all doing the exact same thing. We need to make them all unique. All we need to do is set the B and the value on the math node. We've already set the first row to be 3. On the second row, they both need to be 2, 2 and 2. On the next row, they need to be 1 and 1. And then on the last row, 0 and 0. If you want more, it's a pretty simple pattern to follow. You should have the same number of rows as you have for the count in your mesh line. All right, now at this point, we can triangulate the geometry. So add in a triangulate just after the join geometry. And I like to set it to fixed. At this point, I think it would be nice to trim off the corners so it looks more like a rectangle, but how much should we chop off and how would we do that? As for the amount, I'll spare you the details, but it works out to be 1 and the square root of 3. If I set the mesh line to 1, the rectangle formed by these vertices have a length of 1 and square root 3. And this ends up being the most area you can have for a given rectangle bounded by this perimeter. Trust me, I know. So now we want to chop off any of the faces outside this area, right? We want to chop these off. To do that, let's scroll over and let's plop down a delete geometry. Set the domain to face. It deletes everything, so we have to carve out a selection. Place down a position, a separate XYZ, and a compare. Connect the position to vector, connect the X to the A, and the result to selection. Observe as we play around with the B value, it deletes the geometry. The bounds of this rectangle are going to be plus or minus 1/2 on the top and bottom, and plus or minus the square root of 3/2 on the sides. To chop off the amount we need to set the B value to the square root of 3/2. Then duplicate the compare node, set it to less than, connect the X to the A, and now just put a minus sign in front of it. We need to combine these results with a logic OR gate, so plop down a Boolean math, connect both of these to it, set it to OR, and then connect it to the selection. This will remove the left and the right sides, and if we bring back the other instances, you'll see that it works no matter what the subdivision level is. Now we need to crop the top and bottom. So let's start off by duplicating the compare nodes and the Boolean math node. Connect the Y to the A on both the compare nodes. Now we need another Boolean math to combine both of these. So just duplicate one, combine them up like that, and then connect this to the delete geometry. Since the height of the image is 1, the B values are going to be plus or minus 1/2, so 0.5 and negative 0.5. It's starting to take shape, but the top and bottom edges are all zigzaggy. Let's think for a sec about how we might smooth them out. If you look at the first one, it's coming out by 1/2, right? So from here to here is 1, right? And this point is chopping it in half. So we need to somehow grab this point and then slide it back by half. On the second one, it's coming out by 1/4. So if you work out the formula for this, it becomes 1/2 raised to the index level plus the subdivision level. So if we can grab these vertices and then scoop them back by that amount, we'll be able to make the entire thing flush with this edge. To do that, we're going to need the index, but since we're now working with realized geometry, we don't have access to the index anymore, so we'll have to capture it. Scroll all the way back to the beginning of time. Before we place the next node, you might want to turn off auto offset in the view menu by going to view auto offset if you don't want your layout getting all messed up. Now I'll put down a stored name attribute just after the instance and then move things out the way. It's a lot easier to rearrange this side than having to rearrange this side. Back on the store named attribute, set the data type to integer and the domain to instance. Set the name to something like my instance. Now place down an index and connect it to value. If we press Control Shift left click and look at the instances, you'll see my instance gets the value of the index, which is what we want. Go ahead and delete the viewer. Now scroll back to where we were. This is also a good time to turn auto offset back on. All right, we want to move vertices, so plop down a set position node. The vertices we want to move are the ones above or below plus or minus 1/2. To select them, use a position node, a separate XYZ node, and a compare node. Connect the position to the vector on the separate XYZ, connect the Y to the A, and connect the result to the selection. Finally, set the B to 0.5. If we play around with the Y offset, it'll move the correct vertices, but there's no constant value that'll give you the right answer. It's going to be unique per instance. The pattern goes 1/2, 1/4, 1/8, and so on. We have to create that pattern somehow using the index we just captured. To do that, place down a named attribute node and a math node. Set the named attribute node to integer and then select whatever name you gave it earlier. Set the math node to power. Connect the attribute to the exponent. Change the base to 2. If we view this and then connect our current geometry, you can see that when my instance is 0, the output is 1. When it's 1, this is 2. When it's 2, this is 4. We need to take the reciprocal of that and then half it. All right, so delete the viewer node, duplicate the power node, change it to divide, connect the output of the power node to the B, to the second value on the divide node. We could make this numerator 1 and then divide this output by 2, but it's possible to do all that in one step. If we change this to 0.5, it'll have the effect of taking the reciprocal and then cut it in at half. And it has to be negative since we're pushing it backwards, so go ahead and change it to negative. We have the value we're looking for, but if we plug this directly into the offset, it'll move them along all the axes, which is not what we want. It's moving them backwards the right amount, but it's also moving them down and to the right by that same amount. So we want to separate that out. Add in a combine XYZ and connect the output to the Y and then the vector to the offset. Now the top edge is flush along all the iterations. To finish this up, add in another set position, duplicate the compare node, change it to less than, connect the Y to the A, set the B to negative 0.5, and then connect the result to selection. The offset amount is going to be the previous offset value, but multiplied by -1 since it's going in the opposite direction. Duplicate one of the math nodes, set it to multiply, Set one of the values to -1. Connect the divide to the other. Duplicate the combine XYZ. Connect its output to Y. And then this is going to go to the offset. All right, now it looks right when the subdivision level is 0. But if we start to increase it, it breaks. And that's because we're not accounting for the subdivision level anywhere in this section. To account for it, all we need to do is add it right here. So place down a group input and a math node. Make sure it's set to add. Add the subdivision level, the attribute, and then connect this to exponent. Now when we change the subdivision level, it doesn't break no matter how many we add. Nice. Now that we have the geometry looking good, let's add an image so we can see what it looks like. Place an image texture. Set the extension to clip. What that'll do is anything outside the true image gets set to black. I'm only doing this so it's easier to see where the edge is. The image I'm using has been chopped so it fits the aspect ratio of the rectangle. I've left a few of them in the project file on Patreon. To make your own, you'll have to chop it so the aspect ratio is 1 by the square root of 3. In the video description, I've left a bunch of resolutions you can use. Go ahead and select your image. Once you have your selected file, connect the color to an empty socket on the group output. Over on the geometry node modifier, go over to output attributes and then name the color to something like my color. Then switch over to the shading tab, add an attribute node, set the name to my color. I'm going for a flat look. I don't want any shading, so I'm going to delete this thing and then connect the color directly to the surface. As soon as we do that, you'll notice nothing happens. That's because we need to add a set material. Use the material we just made and then switch to viewport shading. Now we're starting to get somewhere. If we increase the subdivision level, we can start to see an image. It doesn't look very good and the offset is all wrong. Let's make it look a little bit better first. Inside the side panel, scroll down until you see the color output. Change the attribute from point to face. Where it says point, you can switch it to say face for a flat look or edge for a gradient look. I think both can look quite nice. Point and face corners both look fuzzy and unappealing to me, but it might work for your project. It all depends on what you're going for. I'm going to leave mine at face for now. Now let's tackle the offset issue. If we place down a position node and connect it to the vector, nothing will happen, and that's because the vector is based on position by default. But now, if we place a vector math in between it, we can move it around however we want. Now remember, we said the width of the rectangle is the square root of 3 and the height is 1. When the image gets loaded, it defaults to having a corner in the center. That means if we move it over by half of the square root of 3 and then down by a half of 1, this corner will get placed in the right spot. But 1 and the square root of 3 are just arbitrary numbers I picked at random. In the real world, an artist might want to use any aspect ratio, so let's set it up so it's procedural. To do that, let's place an image node. And an image info node. Connect the image to image and image to image. And then go ahead and reselect your image. All right, to get the aspect ratio, we need to divide the width by the height. So place a math node, set it to divide, connect the width to the first socket and the height to the second socket. Now create a combine XYZ, connect the output to the X and set the Y to 1. Then add in a vector math. Set it to divide, connect the vector to the first one, and then set these first two to 2. And finally connect this to the vector add. Oh, and I just realized I didn't set this to divide. I think I misclicked. This will offset the image, so when we scale it up in the x-axis by the right amount, the center of the image will be the center of the rectangle. Now we have the correct offset, but the scale is wrong. Duplicate the divide vector math node and place it after the add node. Set it to multiply, and then set all these values to 1. If we play around with the x, you'll see that it's inverted, right? So larger numbers make the image smaller, and smaller numbers makes the image larger. As we said earlier, this needs to be the square root of 3. You could do some magic, so when you plug this into the multiply node, it works properly, but that would be complicated because the easiest solution is to set this to divide and use the combine XYZ. If we change our image to something with a different aspect ratio, the image is scaled properly and positioned in the center. This wouldn't be possible without the image info node. Another new feature in version 3.5 is the mirror extension. In our case, this works better than repeat because with repeat, if the sides of your image are two different colors, you'll get that color on the wrong side and it'll look bad. At this point, we can start removing faces based on an image texture. We could use the same image, but I think it would look nicer if we ran the image through an edge detection filter first. That way, fine details get added where they're needed. The result should look closer to the original image, even with a very few number of subdivisions. Otherwise, it would be based on how bright a section of the image is, which usually doesn't correspond to the level of detail in that area. In other words, bright areas aren't necessarily sharp and dark areas aren't necessarily blurry. This is optional. The original image will work in a pinch. It just won't look as good in my opinion. So this is what an edge detection image will look like. So anytime the algorithm finds an edge, it'll make that bright. And then when that translates into Blender, we're going to have more detail in that area. You'll see what I mean in a minute. Since we're going to be using two images, they need to be offset and scaled in the same way. So we might as well reuse this logic. Select everything here except the image and the image texture. So these three and then all these. Then group them by pressing Ctrl G and then tapping Tab to back out. Select all three of them and then duplicate them. Swap out the image for the one that's been ran through a edge detection filter. Then slide these three over to where we subdivided the mesh. Then grab everything before this join geometry and slide it far to the left, because we're going to be doing a lot of stuff in here. I'm going to set up one of these and then the rest will be a simple copy and paste job on your part. Start by adding a delete geometry. Switch the domain to face. Add in a compare node. Set its operation to less than. Connect the color to the A and connect the results to the selection. The range coming from the color can be arbitrary. The lowest value might not be 0 and the highest value might not be 1. In fact, that'll usually be the case. So let's make it so it's always the case by adding in a map range between the image texture and the compare node. We don't know what the from min and from max are going to be, but we can find out by adding in a attribute statistic node. Set the domain to face. Use the color as the attribute. Then connect the geometry from here. And then min is going to go to from min, max, from max. An image that has been ran through a edge detection filter usually comes out really sharp. That's not ideal in our case. It would be nice if it was blurred out. So add in a blur attribute and connect it to one of the colors, and then reconnect the other color like that. Now when we play around with the comparison, you can see that the details are showing up where the edges are. And if I change it to 0, it'll have the effect of not blurring it at all. So I feel like when it's at a low value, it looks too noisy. So when we increase it, it smooths it out a bit. And I feel like that gives us a lot more control. All right, so to finish, it's as simple as duplicating these 4 nodes and then just rewiring everything. I'm not going to sit here and do it in front of you because it's going to take too much time and this video is already getting kind of long. In the final version, I've added more controls so you can tweak things without needing to go into the node tree To position the camera, zero out its location, and then set the Z to something big like 5, and zero out all the rotations. Come down here and click on the little camera icon, change the type to orthographic, and then set the orthographic scale to the square root of 3. And now when we look through it, it's lined up perfectly. All right, as for some last minute tips for rendering, if you're going to place this in a scene, go over to the mesh line and set this to something really small, but don't set it to 0. All right, something like 0.01, or else you'll get Z-depth fighting. You'll get some nasty things that look like that. I'm not sure how you would set this up so you could set it to 0. If it's not possible with geometry nodes, it's most certainly possible with compositing. If you're going to be rendering this out as a single image, I would disable the cropping we did. So you can do that by selecting this delete geometry and these two set positions, and then just press M to mute them. That way you won't get any rounding errors on the border of your render. One final thing you might run into is that a 16:9 aspect ratio is really close to a square root of 3:1 aspect ratio, but it's not exact. So if I change one of these to 1920x1080, and then re-enable this, so you might think you'll have an error and you don't know why, and that's just because you need to change this. So it fits that aspect ratio perfectly. You can use this website to find better values for the X and Y resolution. Just type in 1 followed by 1, 2, 1, 2, and follow that pattern. Once you click calculate, these values, this top value will become the X resolution and the bottom will become the Y resolution. If it's too small, just add more digits. Until it gets to a resolution you're comfortable with. And you can always set the multiplier to be like 300 or something. Well guys, that's it for this video. Thank you so much for watching. If you found this video interesting, please give it a like and consider subscribing if you haven't already. Have a good one and take care.